Here is a short video on power. And don't forget, there are also videos at the beginning of this section on positive physics with more specific instruction on how to do problems. So I want to talk about what power is. It is the rate at which work is done. So I want to give you an example. It's not exactly perfect, but it will give you the idea. So my son Trevor, as you know, runs cross country and also track. And this year he is really smoking on the 400-meter run, which he's a long-distance runner. Normally he wouldn't run that. But he can do 400 meters in about 51 seconds. I can also do 400 meters, but it takes me a long time, and I'm going to estimate about 2 minutes. I know that's really slow. So when we think about Trevor and me, we both go around the track. He does it a whole lot faster than me, which means he has more power. So power is the rate at which work is done. It has the symbol, it's a capital P, and the unit is the watt, and the symbol of the unit is capital W. So the formula for power is work divided by time, or, so that's the rate at which work is done, or because work is the change in energy, it's also the change in energy divided by time. Now, here's the tricky part. If you think about the formula in terms of units, power is in watts, work is in joules, and time is in seconds. I will tell you so many times when I see a problem that has like 400 watts, watts is power, but I see that W and I accidentally put it in where this W is. It's a dumb mistake. If you do it, you'll know what I mean. But this 400 W goes where the watts is, which is the power. Okay, there are two ways to think about power. One of the ways to think about it is in terms of just looking at the parameters like we did with Trevor. So I've got race car 1, it has 1,000 kilograms and it goes 400 meters in 20 seconds. Race car 2, also 1,000 kilograms, it goes 400 meters in 15 seconds. So when I think about which car does more work, they're both doing the same amount of work because I have a 1,000 kilogram car going 400 meters. But car 2 has more power because it's doing it in a faster time. So work and power are two different things. Power is the rate at which work is done. So how do we solve power problems? Like I said, I'm going to do a really quick example. So if you want more, you should listen to Jack on positive physics. So we have this example, a winch raises a 2-kilogram cat 2 meters in 20 seconds. How much power does the winch deliver? So if we think about our example, each 0 is where the cat starts, and then 2 meters vertical is where the cat ends up. So initially, I'm not moving because I haven't started moving yet. I have no gravitational energy and there's no spring, and so I have 0 energy. At the end, I only have gravitational because, again, we assume the cat's not moving. And so what we're going to say is that the winch delivered an amount of work even equal to the gravitational potential. So we have work is equal to mgh. And then I just plug in my numbers. I know that mass is 2 kilograms, g is 10, h is 2 meters, and so that gives me 40 joules. So that's the amount of work done. And then to find the power, it does it in 20 seconds, and so that's 2 watts of power.